and welcome back to Victoria's Educational Services, where I break down difficult concepts into easy steps. Our objective for today is to decompose unit fractions using area models to show equivalence. This lesson covers standards 4.nf.3b and 4.nf.4a, and is based on Eureka Math Module 5, Lesson 5. By the end of this video, you'll be able to use area models to show fraction equivalence. Okay, let's get started. Let's start with a concept overview. This will help us solve our next two problems and show us what our thinking should look like when we're using area models to show equivalence of fractions. First, I'm drawing an area model that is partitioned into 4 equal parts. Okay, so here's my area model with 4 equal parts. I'm going to shade one of these in. If this entire figure represents one whole, what fractional part is shaded? If you said 1/4, you are correct. So we have 1/4 that is shaded. Next, I'm going to draw a horizontal dotted line to decompose this whole into 2 equal rows. So watch what happens. So what happened? There were 4 pieces and now there are 8. We cut each fourth into 2 equal pieces to make 8s. There are more parts, but they're smaller. So we realize that 2 times 1/8 is the same as 1/4. How many 8s are shaded? 2 8s. Even though the parts changed, did the area covered by the shaded region change? No. What relationship does this show between 1/4 and 2 8s? Well, you could say it shows that 1/4 equals 1/8 plus 1/8, and that equals 2 8s. Because this whole piece here of 1/4 equals 2 of these pieces here, 2 8s. So we see 1/4 can be decomposed into 1/8 plus 1/8, which is 2 8s. Keep this thought process and these concepts in mind as we solve the following problem. Our problem says to decompose 1/2 as 4 8s represented in an area model, and that's the sum and product of unit fractions. So my first step is to draw my area model broken into 2 equal parts. Then I'm shading in one part, and if this whole model equals 1 whole, what fraction did I just shade? 1/2. So remember, I need to decompose this 1/2 into 4 8s. In our last problem, we drew one horizontal line and we were able to decompose our area model. Let's see what happens this time if we draw one horizontal line. So if you look, you can see that that one line broke this into 4 pieces, but we need to break this into 8s, so one line is not enough. I need to draw 1, 2, 3 lines to break this into 8s. How many parts do we have now? Well, we can count that we have 1, 2, 3, 4, 5, 6, 7, 8 parts. How many 8s are shaded? 1, 2, 3, 4. So we have 4 8s that are shaded. Now let's represent the decomposition of 1/2 as the sum of our unit fractions. So we can write that 1/2 equals, and then count how many 8s we added together. 1, 2, 3, 4. So we have 1/8 plus 1/8 plus 1/8 plus 1/8 equals 4 8s. We decomposed this represented in an area model. We just showed it as a sum of unit fractions, and now we have to write this as a product of unit fractions. So I did a whole tutorial on how to write the product of unit fractions, and I'll link that above because this part can be a little confusing if you did not see that video or if you don't understand that concept yet. So if you need to watch that, you should go back and watch it. All right, so to write the product of unit fractions, I can write 1/8 equals 4 times 1/8, and that equals 4/8. All right, so make sure you did all of your steps. We decomposed 1/2 as 4/8 in an area model. We wrote it as the sum of unit fractions, and we wrote it as the product of unit fractions. Our last problem states to model 1/3 equals 4/12 and represent the decomposition as the sum and product of unit fractions. So our first step is to draw an area model partitioned into 3 equal parts. I'm shading in one of those parts to represent 1/3. If we draw one horizontal line, will the fraction be decomposed into 12ths? No, that breaks it into 6. We need to draw 3 horizontal lines to break this area model into 12ths. Always count your boxes to make sure that it is broken into the correct fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many parts do we have now? Well, we have 12 parts. And how many 12ths are shaded? 1, 2, 3, 4. Now let's represent the decomposition of 1/3 as the sum of unit fractions. So let's write 1/3 equals, and then you write how many times you add 1/12 to get to 1/3. 1/12 plus 1/12 plus 1/12 plus 1/12, and that equals 4/12. Now we're going to represent the decomposition of 1/3 as a multiplication sentence. So we can write that 1/3 equals 4 times 1/12, and that gives us 4/12. And that's it. So you might see this problem worded in different ways, like our first problem was worded slightly differently than the second problem, but don't let that confuse you. If they're asking for a decomposition as a sum and of unit fractions for an area model, this is how you do it, okay? If you have any questions, please leave a comment. If this video helped you, please let me know. Please like and subscribe so I can continue to provide free educational videos. Thank you so much for watching, and I'll see you next time. Bye!